So where are we? We have all of our software updated on the system, and we've just installed Docker and Docker Compose and verified that they work. Our next step is to clone the repository so that we can run this demo. We're then going to configure the firewall so that we open the ports that we need to get into those containers, and configure the firewall to allow the containers to talk to the internet and download resources. And then we are going to start running our demos. Okay, for step one, we are going to clone the repository from GitHub. I'm using a fork that I've made because I've made one or two small changes, but they are very, very minor. So I go into the AI playground. Next up, we need to make sure that we have installed and configured the firewall. So we're going to, again, become root. I'm going to install firewall D. I'm going to start the firewall daemon. And we're also going to enable it so that if we reboot this instance, we will be able to have the firewall still in place. Next, we need to find what the Ethernet interface is for this device and make sure that it's added to the firewall zone that we're using. Let me share why that's important. By default, if we look at the firewall command ---- list all, that will list all of the zones that we have. We have this public zone. Right now, it does not allow IP masquerade. It does not have any ports open, and it does not have any interfaces that it allows to do network address translation for containers out to the outside world. We need to change all of those things. So first, we're going to add the ports that we care about for our demo, 7860 to 7863, and we're going to allow those to be open in the firewall by default. We're also going to allow masquerading, IP masquerade, and then we are going to have to search for an Ethernet device name. So let me run IP A, and we have our loopback device, our Docker bridge, and we've got this device, ENP0S10. That is the Ethernet card, or the Ethernet interface for this virtual machine. And we're going to add that to our firewall zone to allow it to connect to the internet. We still don't see these things show up. We have to run a command called firewall command --reload to actually refresh things. And now those changes have taken effect. And we should be good to go. Okay, so let's look through the demos that we're running, and let's see how this works. Well, in this file, we have a Docker file which creates the graphical application we're not actually going to use today, right? We're going to use Docker Compose and bring up these services manually. There's the readme.md, which contains the instructions for this demo, and requirements.txt that includes all of the system requirements. But let's look at the compose.yaml file, which is going to contain all of the services and their definitions. Now, this is, again, the launcher application. We're not using this today. I'm going to just directly run the demo services. We have the service Yolo demo service, which is running Yolo, a common AI workload. That is going to be exposed on host 7862 of the host. Then we're going to look at Whisper demo service, another common AI workload. This is going to do speech to text and speech to text translation for subtitles. That's going to be exposed on 7863. Each time we will stop the service, the previous application before we start the new one, just to avoid overloading the host. And then finally, we have these two containers, Olama demo service, which is going to serve an Olama instance, and LLM chat demo service, which is going to be our front end, which is going to allow us to talk to that Olama demo service. And that front end is going to be exposed on port 7861. Okay, so we're going to run all of these applications. First up, we are going to run the Yolo service. And to start the service, we run Docker Compose up. We're going to run it in daemon mode so that we get our command line back. and we're running Yolo demo service. Now, the first time we run this, it's going to pull all of the containers we use. This is a once-off process, but it does mean that our first time startup is going to be about 2 to 2.5 minutes. So now the containers have all been pulled, decompressed, and now we're running the service, which involves actually starting the applications. And we're done. So now we will open up the IP address, which I got from the Oracle Cloud Interface dashboard. Now we go to port 7862, which is where our Yolo demo is running. And we're going to choose one of these streams. We can also get to choose a model size and what task we're asking it to do. So I am going to choose driving in New York City. We're going to ask it to detect different objects in the video, and you'll see it will detect cars, pedestrians, etc. And there we go. This is a real-time workload being implemented. It's giving you around 30 frames per second. And you can see clearly that this is giving you more than enough performance running on CPUs to perform a task like automated driving. And that is about all there is to say about Yolo. So let's bring down the Yolo service. And we can see the services that are running with Docker Compose LS. That will tell you that we've got an AI Playground Docker service running. If you Docker Compose PS, that will tell you which containers you're running and so on. But we're going to bring down the Yolo demo service. And we are instead going to switch to the Whisper demo. So for this one, we're going to again have a large pull of a core image. And again, this is a one-time activity. If I were to restart the Yolo service now, it would take about 20 seconds. And because all of that pulling of information from the internet doesn't have to happen. Now we can see this is 2.809 gigabytes of information that's being pulled down and uncompressed. This is file system images, so it's going to take some time for this to complete. Let's see how it does with translation in real time of Mandarin. You'll see it takes a few seconds to get started.
Cloud service 去特制化出来的一个 CPU，OK？ 那接下来要谈到说，整个在 data center 的需求上面来讲，如果从2020年大概是597个 billion dollar 的这个生意，到我们看到大概是2025年整个会变成1.3 trillion 的一个，基本上是一个 double 的一个数字。所以我们做了一些分析，就是说，第一个，我从传统的架构跟现代 ARM 的这个架构，从 power 的需求。
So that's a demonstration that's showing how this can do speech to text. It can also do speech to Mandarin text, just to show you that this is also possible. It can do speech to Mandarin subtitles. It can do speech to translated to English subtitles. Very common AI workload. This is, I believe, reinforced learning neural network style AI, but again, gives very, very good performance on CPU only. We can now stop the Whisper demo service. And we're going to run, and we're going to remind ourselves of the name of the service. This is the LLM Chat demo service. So we're going to run this service. This is going to be the front end, which is going to connect to this is going to create as a dependency the Olama backend service. And this is going to communicate over port number 7861. Again, this takes about 2 to 3 minutes to start up. And our service is started. Now, it's not going to be immediately available, but I can share the screen that it is going to be on. And we will try this every few seconds until the application is available. It'll take about a minute. There we go. So now we have our Llama chat. Now, by default, there are no models in this chatbot. So first, we're going to figure out which models we can use. And to do that, we're going to go to olama.com/library. This is all of the models which are available for Olama downloadable from the Olama registry. Let's try Llama 3. Okay, so let's go for Llama 3.2, 1 billion. So we're going to copy this label. And in here, we've got Llama 3.2, 1 billion. And we will pull that. And in our chatbot interface, we'll go to Llama 3.2, 1 billion. We're downloading the model. The model is being successfully downloaded and installed. And let me think of a good question that I could ask Llama that it might know the answer to. Select a model, Llama 3.2. Are CPUs a good option for small model LLM inference? Let's see what Llama has to say about the question. CPUs can be a viable option. In fact, many modern CPUs are well suited for this work. We provide a lot of cores, thread level parallelism, low memory footprint, cache efficiency. So for small model LLMs, CPUs can be a great option. They allow you to be more efficient in your use of resources. They scale more. The scalability of CPUs across multiple cores is much more granular than the scalability you get across GPUs. And you can really save a ton of money by running your AI inference workloads on CPU. So let me summarize what we've seen here today. We took on the task of walking through the AI Playground demo. We created an Ampere-powered A1 instance on Oracle Cloud that we could run multiple AI demos on. We cloned this repository into that instance after we had done some software updates and installed some dependencies. Then we configured the network on the host to allow us to connect to those containers and allow the containers to connect to the internet. And finally, we ran 3 different demos. LLM chat with Olama, which was able to run a chatbot that provided very good performance on a 64-core virtual machine. Object detection using Yolo v11, which was a video, a computer vision use case, automatically detecting different types of objects in a video stream, and speech to text with Whisper, real-time generation of subtitles and real-time generation and translation of those subtitles into another language. So with that, thank you very much for joining me, and have fun with your own AI experiments on Ampere CPUs.